USB Power Injector. I can't believe I haven't built one of these sooner. A USB power injector passes the ground, D+ and D- signals through, but isolates the power supply. It then provides a separate 5-volt power supply to the attached device. This is done to allow devices to be connected to a PC whilst protecting the motherboard in the event of an overload or a short circuit. Power will be supplied through one of these 5-volt at 3A switch mode DC to DC converters. These are cheap and I've used them in a number of other projects. I will also include a reverse polarity protection diode and a 4A poly switch as additional protection. Connection to the PC is via a USB Type B socket because the cables are abundant and I have some of these sockets in stock. And, of course, I'll use a USB Type A socket for the output as these are the most common and I have some of them in stock as well. It's essential to go to a number of different sources when looking for pinouts to ensure you get the right pinout. When I was looking for the Type B pinout, I actually found one diagram that was completely incorrect. And here is the schematic. There really isn't much to it. And here is the finished board. And here's the ugly soldering. Not my finest moment, but it will be safe. Now for the testing. This must be done carefully to avoid damaging equipment. My first test was done before the power supply was connected. I connected the power straight through and plugged a thumb drive into it, then plugged it into my PC. It's important to ensure that the basic wiring is correct before attempting to test the power injection. Here, I've had some luck with a broken mouse as a source for a test cable. The connections are all labelled on the board. So I was able to label the cord with the colour codes for the wires. A word of caution, the colours of the wires don't always make sense. I've seen plenty of cables where the red wire was not positive and the black wire was not negative. Always check it yourself or look out for devices where the connections are conveniently labelled. And this should help for the other end. And there we have it, an end-to-end probe testing solution. The PCB is now mounted in a 3D printed carrier. Point-to-point wiring on perf boards is not the safest way to make something, so it's always a good idea to protect the solder side before testing. Once the testing has passed, the PCB carrier will prevent anything from coming in contact with the exposed wiring and causing a short circuit. Plan a testing strategy that covers every combination of good and bad connections, regardless of whether they seem likely. What you are seeing here is just the first 16 tests. I am basically testing each of the 4 connections to the device end against each of the 4 connections to the PC end. This ensures that the D+, D- and ground pins all carry through, but VCC does not. This also ensures there are no short circuits. I have not shown the grounding tests where I check the ground connection at the terminal block and ensure it connects to the grounds on the switch mode module and both USB connections. Finally, there was the connections through the diode, again ensuring nothing connected to either USB socket. So Now for the smoke test. Off camera, I plugged it into my USB hub and powered it up. I plugged in a thumb drive and it worked fine. Now for the real test. Here I have an ESP32 connected to it, and it's connected to my USB hub. It powers up fine, but will I be able to program the ESP32? I would call this project a success, and from now on my motherboard will be protected. So, after 15 plus years of connecting homemade projects to my PC's motherboard, why make this now? Once upon a time, there was a YouTuber whose videos had terrible sound quality. I wonder who that was. So, he bought a wireless lavalier microphone. He was so excited he made his first unboxing video. You gotta see this one, it's a doozy. The receiver. This plugs into the PC or phone. And here we have a USB breakout board that I'll use to check the device. And my multimeter. Now, let's test the resistance between the VCC and ground pins. It's really awkward trying to get the board, probes and multimeter LCD all in the screen. That's right, 0.1 ohms. So this little receiver wants 50 amps. This is obviously a dead short. Of course, full disclosure, the unboxing video was made after I had actually unpacked the microphone and plugged it into my PC. Most motherboards should have overload protection in case of a damaged cable like this example. But a short circuit is not the worst that can happen. If a wire is connected incorrectly, it is possible to put a higher voltage into the USB port. This would damage the power injector, but you would have a chance of saving your motherboard at least. Of course, I wanted a USB power injector in a hurry, so I made one. But there are off-the-shelf options. I ordered one of these and it just arrived. It is not suitable as the 5-volt connection goes to all 4 sockets. However, if you're feeling butcherous, you could desolder this pin, then cut it off completely and provide 5 volts from the pads on the other side.